So when you get complicated polygons that don't necessarily conform to the regular polygons that you're used to, one of the things you can do is draw some lines and reduce it to more familiar figures. By drawing that line across there, we reduce it to a right triangle and a rectangle. Now since this the rectangle has a height of 1, that makes this number 1 and then this height of the triangle into 5. We also know that the distance across the top is the square root of 61. So from here, we can use the Pythagorean theorem to figure out the area, to find out this remaining side. We'll call it x, and then we can that'll also be the length of the triangle. So the number we're after for the total sum of the area of the figure is going to be the area of the triangle plus the area of the rectangle. And both of them require x, so we have to do a little bit of work still, but we need two numbers added together. Let's start with that Pythagorean theorem. Remember that a squared plus b squared equals c squared when you have right triangles. And we know two of these numbers, so we can find the third. We'll call x will be our a, 5 will be our b, and the square root of 61 will be our c. So we have x squared plus 5 squared equals the square root of 61 quantity squared. So x squared plus 25 equals, so when you square the square root, that just equals the number that's there, 61. X squared equals 36, so x equals 6. So now we know we have a 6 here and a 5 here and still square root of 61. But we don't need that anymore because now we're dealing in area. Remember that the area of a triangle is 1/2 the base times the height. So that's 1/2 the base, which is 6, times the height of the triangle, which is 5. And the area of a rectangle is length times width. The length is 6. The width is just 1. So 6 times 5 is 30. 1/2 of that is 15. 6 times 1 is 6. 15 plus 6 equals 21. Answer choice D.